physics, mechanics. So we're nearly finished now, mechanics. We only have 3 more topics to do, and we're going to do 2 of them today. Or we'll try to do 2 of them today. Circular motion. So from the name you can probably guess what type of motion this is in a circle. But unfortunately the formulas are different for motion in a circle. It's not like UVATS. We can't use the same formulas, unfortunately. We need to use different formulas. Okay, let's scroll. Okay, so there's some formulas too. Okay, so a circle, no less. So just to make sure you all know the names of the different parts of the circle. So I know some of you will know it already. So this is really, I'm going to pick on Sean, Jerry, Bruce. Yeah, okay. Sean, Jerry, or Bruce, or Brian. Do you know the name of this part of the circle, the or? Very good, radius. Okay, Brian got 1. Sean, Jerry, or Bruce, do you know the name of this part? Very good, thank you. So, Sean and Jerry, this leaves you with the hardest one, this one.
I know.
What's it in Chinese? Correct. What's it in English? No dictionary. No dictionary. Sean, do you know it?
No. I don't know in Chinese.
Okay. What's it in Chinese? Yeah. Okay. Does anyone else then know it? The name of the S part? Now, it's close to sector is actually the name of the whole piece. Just the outer part actually has a different name than sector. Circumference is the whole outer part, just a portion of it.
Sector?
No, he just said sector. Arc, yeah, very good. So the S is called the arc.
Oh, it's not even S.
So theta is the angle, or is the radius, and S is the arc. It's not too cold. Do you see me wearing my coat yet?
We shouldn't study in season 2. Yeah. We can't study.
What? Look, the heaters are on.
This doesn't work.
This doesn't work?
Yeah.
That's funny.
We should have.
No, it's not too cold. It's not too cold. Did you walk to school?
Yeah, I did.
Me too, I walked.
Yeah, we walked to school.
Look,
We even missed the bus.
Yeah.
You have your protein shake. Okay. Right, did you write these down?
Yeah.
Oh, come on, it's not that bad. Look, like I said, Monica's from Kenya and she's not complaining. You're coming, huh? Not as much as she is. Okay, well, in fairness to you, Monica, you're not complaining as much as the other students. Okay. Let's continue then. So in physics, when we're looking at motion in a circle, we do not use degrees. We use a new unit called the radian. So the radian is about 57.3 degrees, roughly. The reason why this is important will become clear in math class. If you want to know the exact value, 57.3 is 180 over pi, exactly. Yeah. So for physics, it's important because the formulas we will use only work when we use radians. So for this lesson we must use radians. And 1 radian is 57.3 degrees. So please note that value. KJ, could you move the projector a bit to the left, please? Thank you. Bit more. A bit more. Left, this way. Okay, that's good. That's good, thank you. Okay, you got this? Yeah. Can I continue? You just need the value here, 57.3. Okay. So here are 2 quick, easy questions I want you to do for me. I want you to change 0.25 radians into degrees and 30 degrees into radians. – 0.25 radians into degrees. Come on. Come on. Well, we'll just give everyone a chance, but that sounds good for the first one. Let me open the calculator here quicker. Okay, do we have the first one done?
Yeah.
What did you get for the first one? Bruce, what did you get?
15.3.
Say again?
15.3.
Are you sure 15.3? I got 14.3.
Oh, fine.
Did you mix up the word for 14 and 15? That's a problem. Okay, try the next one now. 30 degrees into radians. Yep.
0.52.
Yeah, about 0.52, about half a radian. Yeah. Yeah. Yeah.
Okay.
Did you all get that? Yeah? Okay, continue. So we've seen 2 types of motion so far in physics. We've seen SUVAT motion in 1 dimension and SUVAT motion in 2 dimensions with projectiles. So we'll now look at a new type of motion in 2 dimensions, motion in a circle. So what makes something move in a circle? So the definition you need for the exam: if an object is moving in a circle, then it's because there's a net force acting on the object which is perpendicular to the velocity and is directed towards the center. In other words, if I just draw it here real quick for you, if I can. So this direction here is the velocity, and this direction is the force. And if the force points towards the center and perpendicular to the velocity, then this will make it turn in a circle. So that's what I mean here when I say it's perpendicular to the velocity and directed towards the center of the circle. This is a definition which is pretty common for the exam, so please write this down carefully. Yes. Oh, now it's finally opened. Got that? Not yet? Okay. Got that now? No? Okay. No? So, now that we have the definition of this, let's continue. Come on. Okay, so I already drew that. So just a little bit of vocabulary here. This word, centripetal force, is the type of force that acts on a body that revolves around a center. This force keeps the body in circular motion, and it's always towards the center. Wait, before you write this down, in other words, that force here, its name, we call it a centripetal force. I don't think you need to write all of this. The key thing here is the name of this force is centripetal force. Centripetal is an adjective. What do you think it means? Towards the center. Center force. Yeah. So, write something, but it doesn't need to be all of this. Just something. Okay? Oh, Sean, after this second class, if you come to the office with me, I need to print out all the lessons you missed. So you will have lots to do during the holiday.
Yeah.
Lots to do. Huh? The holiday in like 2 weeks. Trust me, I'm counting down to it. Okay, continue. Yeah. So, but Newton said F equals ma. So where there's a F, there's an A. Where there's an A, there's an F. In fact, if m was 1 kilogram, then we have F equals A. My point is, where there's a centripetal force, there's also a centripetal acceleration. Because remember, Newton said F equals ma. So A is just F over m. So, where there's an F, there's an A. Where there's a centripetal F, there's a centripetal A. So you have centripetal acceleration. It's a type of acceleration that acts on any body that revolves, it's the same thing again. It's the acceleration towards the center. So, note that word, centripetal acceleration, please. Okay, you got that? Yeah? Okay, let's continue. Not yet? Okay. You don't need to write the whole thing. Continue. Yeah. Okay, so some terms now. So we have something called an angular velocity. This is how quickly the angle changes, and the units would be radians per second. So just before you write that down, let me just show you a little picture here. So you have a circle, and this is moving in a circle. And it's going around like that. And if in each second it travels 1 radian, then we say its angular speed is 1 radian per second. Okay, so this is what I mean when I say the angular velocity. Okay, do you have that? Yeah? Okay. Right. So I've already explained what it is. I think some people might already know what this probably is, the periodic time. What would you say that is? Go on, Sean, tell us. Go on, explain in English, you can do it. No, don't worry, try to explain. We understand your English. Oh, go on, Sean, don't be shy. Yes. Go. Yes? Correct, yes. It's the time for one cycle. This is the periodic time. So it's the time for one orbit. Orbit is another word for cycle. Of course, the units are seconds. If t is 2 seconds, then it takes 2 seconds for one orbit. Okay. Yes. What do you mean? Say again? Oh yeah, like a turn. Time for one turn. What term? Yeah, which term? Oh, it's a term for the time for the circle, yeah. Do you need to go?
I need to go to hot chocolate.
Okay. Continue? Okay. The units per second has a special name. We call it a hertz. So that is 1 hertz is 1 per second. The reason we need this unit is for something called frequency. What's frequency? Say again? Yeah, go on. I didn't hear you.
How many you change
Very good. No, you just have one word wrong. It's nearly perfect. So as Jerry was saying, it's how many you change in a unit time. It's not change, it's how many you complete in a unit time. So if it's 2, it means 2 complete turns in 1 second. Yeah, very good, Jerry. So the frequency f is the number of completed orbits in 1 second. The units are per second. If f is 2 hertz, then 2 orbits are completed in 1 second. If f is half a hertz, then only half an orbit is completed in 1 second. Do you understand this term, frequency? Yeah? Got that? Yeah? Okay, continuing. So, we have some formulas for circular motion, just like how we had formulas for UVATS. The proof of these formulas is a little bit too difficult for this course, so you won't be expected to see the proofs, unlike UVATS. So I'll just give you the formulas. So the first formula relates T and F. That T equals 1 over F. Or you could also say F equals 1 over T. So this is formula number 1. So write that down, we'll continue. Got that? The second formula is omega is 2 pi over T. Or you could say T is 2 pi over omega. The third formula gives us the velocity in meters per second. So the velocity, the linear velocity, is equal to the angular velocity multiplied by the radius. V equals omega r. And just to be clear, the unit here, meters per second. Here, what's this unit? Radians per second, and this one? No? Meters. Yeah. Okay, fourth formula. The fourth formula gives us the acceleration towards the center. The centripetal acceleration is equal to v squared over r. The centripetal acceleration. That's formula 4. And that's it. It's just the 4 formulas. Yep. Okay, let's have a look at some examples now. Cold? Some examples will warm you up. It'll make you strong.
Eat small.
Yeah, true. Yeah. Have a protein shake. Yep. Okay, continue. A CD, you all know a CD. I know it's not like iTunes, but you still know what CDs are, don't you?
CD.
Yeah, what's a CD? Yeah.
They don't have CD in our generation.
Oh!
Yeah, it's okay.
Huh?
Well, maybe they really don't.
Like a DVD, yeah. Anyway, a CD spins at 500 RPM. Does anybody know RPM in English?
Radians per meter.
Radians per meter? No.
Radians per month.
Almost. It is per minute. Like rounds. Revolutions per minute. So it means 500 turns per minute. Per minute 500. What's the omega? Okay, let's calculate the omega here. So the CD spins 500 times per minute in a minute. So that means it's 500 over 60 in a second. What is this? This is actually the F. It's how many per second it completes. Isn't it? What is that? So now 50 over 6 is 8.33. So it spins 8.33 times per second. In 1 second it spins 8 times about. Okay, so we know omega equals 2 pi over t, which is 2 pi 1 over f. Multiply, yeah, 2 pi f. So I get 52.4 radians per second, and that's my answer. Now that's pretty fast, because remember 1 radiant is 57 degrees. So if we just multiply this roughly by 57, you're saying that in 1 second it turns about 3,000 degrees in a second. So it's spinning quite fast. Okay, write this example down. We'll do more examples now. First example. Continue, you got this?
So why asking for 500
That 500 is for 1 minute. We need to use it for 1 second. So we must divide by 60. Oh yeah, there's a couple of ways to do it. Are you saying we could have worked out the t? Yeah, you could have done it this way as well. Yeah, that's fine. Okay, continue. Okay. So that was our first example, so that was okay, not too difficult, but they can get a bit more difficult. So let's see the next example now. Okay, so again, I'll do it, but I want you to write or draw this story. So a car takes 5 seconds to drive around a roundabout of radius 6 meters. How fast is the car traveling? Okay, try to draw this or write it. Do you all know what a roundabout is? Let me get a picture up. That's a roundabout. This is a roundabout. Okay, did you draw that? Yeah? We'll do it now? Well, I'll draw it now anyway. Okay, so what you're told here, what did I say? 6. Come on, computer. I will only change it when it stops working completely.
No,
It's not working.
It's still on, isn't it?
no.
It's free.
Yeah. His kill.
Your phone isn't working.
If it's cold, it should work faster.
Why? Rest too much.
Yeah.
No, I think have to cold weather.
I don't know that.
It doesn't work on cold weather. Really.
What doesn't work in cold weather?
An iPhone.
Yeah, my laptop has the same trouble as an iPhone.
It doesn't like the cold weather.
Really?
Yeah,
Yeah,
Yeah.
it's working well.
Put this on shirt.
It's made for California, I guess.
Yeah. No, it's made in China.
Yeah. Yeah.
Cheap.
Cheap.
No.
Okay.
No.
No, I want the chip inside.
Cheaply made.
I mean
Yeah.
the chip inside is made in China.
Come on.
It's because it's winter.
Go. I'll just, no problem. I'll just open up another pad.
Sure.
Dang. Oh, it's orange.
Which one is it? Office, maybe. No. Graphics. System?
60,
Yeah.
right?
No, not 6. Yeah.
No, yeah.
It's
Not
double.
50. 50. 6.
Okay, until my writing pad comes back, I'll just use paint. Good old paint. You can always
Like a
count.
brush?
Yeah, you can always count on paint.
Because of the
And two, I come from it, it's on the, I go 12, you go 12, 15.
Ah, it's back. Okay. Right. What did I say the radius was here? 6 meters. And what else did I tell you? 5 seconds for the time. And what did I want? The V. Okay, so the formula is V equals omega or. Omega is 2 pi over T. So this will be 2 pi over 5 times 6. Right? I don't need you anymore. So that's 12 pi over 5. What's that about? 1236 over... Is it about 7.5? What is it?
7.56.
I was pretty close. 7.56 meters per second.
Isn't it 7.5? 5.4?
Is it? Okay, well. 5.4? Okay. Okay, got that? Next one now. Okay. A 10,000 kilogram plane is banking and it takes 1 minute to circle a path of a kilometer. Does anyone know this word, banking? If a plane is banking? No. Not quite turning in a circle. Banking is not quite this, no. Banking is when the plane does this. It leans to one side. This is called banking. So the reason the plane banks is so that it can turn. So the plane flies straight and then it banks and this lets it turn. So it's 10,000 kilograms and it's banking and it turns in a big circle of radius 1 kilometer. So if you're looking from the top, what you have is a picture like this. Here's the plane here, and it's 1 kilometer, and it's 10,000 kilograms, and it takes 1 minute. If you're looking at it from the front, here's the plane here, and it's banking. Okay, and this is looking at it from the front. Yep. So let's draw the forces here. I have 2 forces. What are they? Well, first one is the Weight. Yeah. And what's the other one? Not quite, actually. Not quite. There's only two forces here. The weight. No, not centripetal. Yeah. But you're right, Jeremy's right. It's a type of reaction force here. It's what's called the lift. It's what makes the plane go up. The lift force. Now this is where you have to be careful. There is no centripetal force. We didn't make a centripetal force. Instead, what's happening is there's two forces here. And if this is the L and this is theta, this is L cos theta and this is L sin theta. And this is the centripetal force. This one is the centripetal force. Okay, so let's see what my question is. My question is, what is the centripetal force? This is the centripetal force. Okay, so let's calculate the centripetal force. It would be L sin theta. Well, do we know L? No. Do we know sin theta? No. But we do know that L cos theta is equal to mg, the weight. Okay, so we can know L is mg over cos theta, but the problem is we don't know the theta, so we're a little bit stuck. But we also know that this is equal to mv squared over before I get to that, this is equal to ma, so we can say that A equals L sin theta over m. Now we have a formula for A. V squared over r, yeah, so we can say V squared over r is L sin theta over m. So let's see which things we know and what things we don't know. Do we know L? No, not yet. Do we know sin theta? No. We know this? We know this, and do we know this? So let's change this. We know that V equals omega r. Do we know omega? Well, not quite yet. No. But we can know omega because omega is 2 pi over t. So, do we know this now? Yeah. And do we know this? Yeah. So, do we know this? Yeah. Okay, so let's put that back in here. So now we get 2 pi r over t squared over r. So we know equals L sin theta over m. We know and we don't know. Okay, so now let's look at this part. Earlier we said L cos theta equals mg. So I could say L equals mg over cos theta. So now I get 4 pi squared r squared over t squared over r equals mg over cos theta sin theta over m. Now let's see what we know. I know this, 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 I know this. And what's sin theta over cos theta? Tan theta. So now, and also we can do some cancelling here. Cancel, 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 cancel. So now we can say 4 pi squared r over t squared, and then g here, if I bring that underneath, that's equal to tan theta. Great, so I can get theta. If I get theta, then I can get L. If I can get L, then finally I can get F. Okay, so let's calculate. For pi squared times 1,000 over g, and what's 1 minute is the time, isn't it? 60, yeah. This is tan theta. So tan theta 48 degrees. 48.2 degrees or 48.18 degrees. Okay, so now we can get L. What did I say L was? mg over cos theta, wasn't it?
Yeah.
Okay. So this will be fraction 10,000 multiplying 9.81 over cos my answer. So the L is 147,133. Newtons. So finally I can get the F, which I said was L sine theta, yeah. So I take this answer and multiply it by sine 48.18. Okay, let's divide this by 1,000,000. No. Divide it by 1,000. 109.6 kilonewtons. That's the force here. Okay, now this is getting harder. It's getting harder, so please write this down carefully if you can follow it still. And this is the type of question you get in the exam. What's wrong, Jerry? You okay?
This is the math notebook.
You did your physics in your maths notebook? Oh my goodness. This is a disaster. It's okay. I forgive you.
Teacher, why ask me for this
F equals v squared over R? Did I say that?
Yeah, you said v squared over R equal L times V over R.
Wait, where am I looking? 1, 2, 3, 4, 5, 6, 7, 2. Which part? This one? This v, oh, this part?
Yeah.
No, this is A. Is v squared over R. Yeah. And A is F over M. So, yeah.
A equal F over M equal v squared over R.
Yes.
No.
A is v squared over R, which is F over M, yeah. Yeah. A is v squared over R, and it's also F over M. Yeah, that's what happened here. My beautiful drawing? Which drawing? Oh, the original drawing? Yeah. Well, if I zoom out more, can you still see it? Or is that too unclear? No, that's not clear. You got what you needed, or you...
No, I just wanted to do it.
Okay, yeah. Can I scroll down? Which are you drawing both pictures?
Yes.
Okay. Yeah, what's happening here is this force, its only job is to cancel this force. Okay? But this force, its job is to make it turn in a circle. So this is a centripetal force. So because this is a centripetal force, a force that causes it to move in a circle, we can use all our formulas on this force.
But
yeah?
Doesn't the force have to be the same equivalent to the center?
And it is, because if I'm looking at this straight on, it's moving in a circle like this. Like I'm looking at it straight on. So the center is actually like somewhere like here. And this force is straight towards the center. If you're looking at it from the top, that L sine theta will be pointed towards the center. The L cos will be pointed up towards me in the picture, coming out of the page. This is looking from the top and this is looking from the front. Okay. Okay. Do we have this? No? Okay. I'm sure in one of the instruments it outputs things like the centripetal acceleration and all that. Because that's what makes it turn in a circle.
Is this 7 marks in exam?
I don't think it's 7 marks in the exam. Maybe 5 marks.
Only 5 marks.
Maybe. No, you know what? It might be more than 5 marks, because I think the question I saw was 5 marks to get the angle. Okay, continue. Oh. Continue. Okay, I'm continuing. Right. I think there's 2 more examples, yeah. Okay, a boy swings a 1 kilogram object around in a vertical circle of radius 2 meters at a rate of 2 hertz. How fast is the object moving? Okay, so I think this one is a little bit easier than the last one. So he's spinning something around in a circle. The frequency is 2 hertz. The radius is 2 meters. And the mass is 1 kilogram. And I want to know the V. Okay, so V equals omega or, yeah, omega is 2 pi over T, or, which is 2 pi 1 over F, or, which is 2 pi F, or, which is 6.2830 times 2 times 2, which is whatever 4 times 6.28 is, so 24, 36, 20 something. 3.1415 times 2 times 4. 25.1 meters per second. Oh yeah, it is, yeah. It's quicker for me to type it than to shift, press, stuff like that. Okay, that was an easy one.
When will you use that I?
Yeah, exactly. I didn't need to tell you the M here. Okay, continue.
What is 2 pi over?
T. It's a T. 1 over F. Yeah. Okay. Continue. Last example. A ball rolls inside a sphere of radius 5 meters and it forms a circle of radius 4 meters. Okay, I'll give you 20 seconds to draw this picture. I want to see what you come up with. A ball rolls inside of a bigger ball, a sphere. Yeah. Anybody got the picture? Okay, let's see. So a ball rolls inside of a sphere. So you have this big sphere here, and a ball is inside of it, and it rolls around inside of it, on the inside. Touching the inside of it, yeah. You got the idea? Yeah. So, I'll just put this in red. It's traveling on the inside of the sphere in a circle like this. What's the radius of the sphere? The sphere has a radius of 5 meters. And this one is traveling in a circle of radius 4 meters. Which means this distance here has to be 3 meters. And my question is, how fast is it rolling? And you might think, you don't have enough information, but you do. So let's draw it here on the side. So you have your ball here. There are two forces. The weight, which is mg, and then the reaction force here, which is or. But this has two parts. This part, which is or cos theta, and this one here, which is or sine theta. So you can say or sine theta equals mg. And what type of force is or cos theta? It's a circular force. So because it's a circular force, you can say it's equal to mv squared over or. Okay, now let's do a little bit of magic here. So let's put in what we know. Do we know the m? No, I don't think we know the m. Do we know the g? We know g, yeah. Do we know or? No, we don't. Do we know sine theta? No, we don't. Do we know m? No. V squared? No. Or the radius we do know. What is it? Is it 3? Is it 4? Or is it 5? It's 4. That's equal to or cos theta. What I'll do now is I'll divide these. So I get g over v squared over 4 equals tan theta. So I get v squared equals g over tan theta, 4g over tan theta. Yeah, that's the v squared. So the v is 4g, root 4g over tan theta. But I can get the theta here. The theta will just be tan inverse 3 over 4 from the picture. Yeah. So let's see. Tan inverse 3 over 4 is that. So it's root 4g over tan theta. And the answer is 7.233 meters per second. To which one? The plane, yeah, it is similar to it, yeah. Maybe even a little easier. What do you think? Or the same? Easier or the same? Yes. You need a picture. What I like about this question is that it doesn't seem like you have enough information, but you do have enough information. It was enough just to tell you the two radii, the 5 meter and the 4 meter. It was enough to tell you that, and you could work out the V. I didn't need to tell you the mass or the time or anything like that. So I think this is a very interesting example because it seems like you don't have enough information, but you actually do have enough information. I think this is what makes it harder than the UVATS problems, because in UVATS it's kind of clear if you have enough information or not. But these questions, it's not always clear if you have enough information and how to use the information. Is what makes this hard. It also depends on how you see it as well. In the exam they should provide you with a picture, which will help. Okay, continue. So, I think what we'll do, normally I like to make this lesson a double lesson because there's so much to do in it. It can be quite difficult, and you have 7 questions here. So before you start the questions, I think you probably need to take a break and get a hot chocolate. You were going on about hot chocolate. Maybe someone will lend you hot chocolate money. Look at how cold she is. Okay, do you want to take a break, or nobody has any money to get hot chocolate? You want to take a break? Yeah. Okay, take a break for 5 minutes, and then we'll have a look at these questions then.
What is the